In Interstellar, time dilation isn't just a cool idea, it's real science. Join us as we break down how black holes slow down time and explore the mind-blowing physics behind it. In Interstellar, time dilation takes center stage. This phenomenon occurs when time moves differently in strong gravitational fields like those surrounding a black hole. Miller's planet, near the black hole Gargantua, exemplifies this. Every hour on the planet equals 7 years back on Earth, due to Gargantua's immense gravity. Gravity warps space-time, slowing time as gravitational force increases. Imagine two astronauts, one near a black hole and one in empty space. When person A shines a laser, its frequency diminishes as it climbs out of the black hole's gravity well, causing a redshift. For person B, the signal takes much longer to arrive, illustrating time dilation. While time ticks normally for person A, it stretches for person B. In reality, time dilation happens on a smaller scale, like on the ISS, where time moves slower than on Earth. Interstellar captures this concept through its portrayal of extreme gravitational forces. In Interstellar, time dilation plays a crucial role, especially when the crew visits Miller's planet. This planet orbits close to Gargantua, a massive black hole. Because of its proximity, the planet experiences extreme gravitational time dilation. Every hour on Miller's planet equals 7 years back on Earth. This effect is explained by Einstein's theory of general relativity, which tells us that time slows down in stronger gravitational fields. When Cooper, Brand, and Doyle land on Miller's planet, their clock is ticking much slower compared to those back on the ship and Earth. This creates a high-stakes situation where the crew must complete their mission quickly, knowing that each second they spend on the planet will cost years for their loved ones back home. The scene where they return to find Romilly, who had aged 23 years, is a haunting representation of the effects of time dilation. Time dilation occurs when an object moves at a significant fraction of the speed of light, or when it's in a strong gravitational field. Miller's planet is so close to the black hole that the immense gravitational pull significantly warps time. This phenomenon is known as gravitational time dilation. In simple terms, gravity can bend time. The stronger the gravitational field, the slower time moves for an observer within that field compared to someone far away from it. In the case of Miller's planet, the black hole Gargantua is the key player. Its immense gravitational pull creates a time differential between those on the planet and those farther from the black hole. This concept has real-world scientific backing, although the extreme effects seen in the film push the boundaries of what we currently understand. Beyond the scientific wonder, the time dilation plotline carries deep emotional weight. For Cooper, the realization that he may never see his children again due to the time differential is heartbreaking. When he returns to the Endurance after spending mere hours on Miller's planet, over 20 years have passed on Earth. The scene where he watches video messages from his now adult children is one of the most emotionally charged moments in the film. The time dilation issue is not just a scientific obstacle, but also a personal one. It creates a disconnect between Cooper and his family, heightening the emotional stakes of the story. Cooper left Earth with the hope of saving humanity, but each passing second puts more distance between him and the people he loves. Another aspect of time dilation in Interstellar is how it affects light and space around Gargantua. The black hole's depiction was praised for its scientific accuracy, thanks to the involvement of theoretical physicist Kip Thorne. The gravitational lensing seen around Gargantua is a direct result of the black hole's intense gravitational pull, bending light in ways that make it appear like a glowing halo. The black hole itself is not just a visual spectacle, but a key element in the time dilation problem. As Cooper plunges into the black hole in the film's climax, the gravitational effects become even more extreme, and time becomes nearly incomprehensible. Now let's dive into one of the most mind-bending parts of the movie: Cooper's journey into the tesseract inside the black hole. The tesseract is a higher dimensional construct created by future humans to allow Cooper to communicate with his daughter, Murph, across time. Inside the tesseract, time is represented as a physical dimension. Cooper can view different moments in time as if they were locations in space. The film represents time as a fourth dimension that can be traversed, much like we move through the three dimensions of space. This visualization of time as a physical dimension is rooted in the concept of space-time from general relativity. Cooper uses gravitational anomalies to send messages back to Murph in the past, helping her solve the equation that saves humanity. The idea that gravity can transcend time and space is key to the film's resolution. The tesseract scene is not just a visual spectacle, but a representation of higher dimensions. The back face of the tesseract corresponds with Murphy's bedroom, and multiple moments in time can be observed from different viewing angles simultaneously. The scene represents time as a dimension that Cooper can navigate, traveling back and forth to different points in Murph's life. This higher dimensional space allows Cooper to interact with time in ways that are impossible in our three-dimensional reality. The film uses the tesseract as a tool to visualize how time might look in a higher dimensional universe. One of the central themes of Interstellar is the concept of predetermination. The entire plot hinges on a predetermined loop of events. Cooper's journey through the wormhole, his fall into the black hole, and his communication with Murph were all set in motion by his future self. This creates a causal loop where events in the past are influenced by actions from the future. The film plays with the idea of free will versus fate. Was it always destined that Cooper would send the message to Murph? Could anything have been different? The movie suggests that time is fixed, and no matter how much you try, you cannot change what has already been set in motion. In conclusion, Interstellar tackles the concept of time dilation in a way that is both scientifically grounded and emotionally resonant. The film not only introduces audiences to the mind-bending effects of relativity, but also explores how these effects impact human relationships and choices. As we've seen, time dilation is more than just a plot device in Interstellar. It's a crucial element that drives the emotional and scientific core of the film. The extreme time dilation on Miller's planet, the tesseract's higher dimensions, and the predestined time loop all contribute to one of the most thought-provoking science fiction stories ever told.